Hi, I'm Everett. Welcome back to the shop. I know it's been a few weeks since I've posted last, and partly due to the fact that we had a pile of company, and then I don't know if you can hear it in my voice, but I'm just finally getting over a really nasty bug. Both myself, actually, my wife brought it home from work, and she's a nurse, right? So they're around all sorts of sick people, including sick coworkers. So yeah, she brought this one home from work, unfortunately, and yeah, it went through her system, and then eventually, well, little man and I caught it. So it's been an interesting last couple of weeks, let me tell you. But now that I've had a chance to get back out the shop, I finally had a chance to get at a project I've been wanting to do for a little while. There's a jig I've always wanted to make to mount to the lathe cross slide, to basically use it for line boring or certain types of operations, where you put your workpiece and mount it to the carriage and then use the chuck to hold your tool. I know a number of guys do this on a regular basis for milling operations just because of the way that their machines work. Rob in Australia is one that comes to mind especially. His channel's name is Zainudu or Zinudu. I honestly don't know how to properly pronounce it. I've been meaning to ask him, but yeah, he's used his lathe a lot for milling operations. Well, what I'm thinking for my lathe is, because of the fact that I don't have T-slots in the cross slide, and after looking at some of the other videos of other guys who are doing different things, it looks like some of the older lathes, like some of the Colchesters, I think it was the Colchesters anyway, some of the older lathes actually have T-slots in the cross slide for using as a mounting surface. Mine does not have that. It's one of the ubiquitous Chinese 12x36 lathes. So as I say, as we step through this process and try to figure out how to make this work, I hope you find it interesting. So the other day, as a test, once we got the misting system set up, we took a skim off the one side of this block. Let's get the other three sides that need to be cleaned up done, and then what I'll do then is I'll show you what we're going to be doing with this block. This side's already cleaned up, so we'll just flip it over. So we're looking for roughly 5.9 inches. We got 5-inch 922. Again, the dimensions, I just drew the dimensions up to what I can actually cut out of this small piece of scrap here. I got this from a local fab shop. It was in part of their scrap bin, so at least I got it fairly cheap. The tolerances on the outside dimensions of this are actually not super critical, thankfully. Let's just take the 22. Well, according to this, we're within a thou. Good enough. Because I don't assume that I don't assume that the ends were cut in any way, shape, or form square. There we are. That's square. So now theoretically I should be able to take this top surface off And once that top surface is cleaned up, I should be able to cut it to length and square up the other side. And the outside 4 edges should be square, theoretically. Okay. Let's take a 20th cut. I don't want to go too crazy because I don't want to go too crazy with this because it's actually sticking out of the vise quite a ways. These machines aren't the most rigid to start with. There you go. All right, but yeah, there's a little bit here that it didn't touch on the very edge. I'm not worried about that. It will still be able to be flipped over and put in squarely the other way. There. Now I'm going to leave this edge here sticking over just a smidge, because that way I can use that to measure from. And that should be square once I snap it down. There we go. We need about 7.5 inches long. 7-inch 535. So we'll have plenty there to cut it to length and make it nice and square. Nice touch off. Right there. Do 20 thou. Takes a little bit to get the siphon going, but once it's rolling, you can scale it back. And after that, we are within a few thousandths of 7.5. Good enough. The reference corner is actually on the top, so I'm going to have to pick a reference corner, then flip the block over, and then oh, excuse me, and then come up by 2.3 inches, and then inward by 2.95, and that's going to be the center for both the bolt circle and the hole that sits on that little stub in the cross slide. And then from there we can start drawing up our bolt circle. So this is going to be our master corner, meaning if we flip it over, now measuring from this corner here, inward and upward. Inward we're looking 2.95 inches. And again, I did draw the plan on this one so it had a little bit of forgiveness. Again, it's not, as John would say, we're not building the end cap for a nuclear reactor. And 2 point, oh, missed that one. Try that again. Man, really doing well today. Try that 2.95 again. Hey man, I never claimed to be anything but human. Alright, that is going to be our center reference mark. So let's make a center punch there. From there, give me a minute. I'm going to put some layout dye in here and make this easier for everybody to see. I'm leaving the scale on it. partly because it doesn't really matter for this particular situation if it stays on, and I don't have a fly cutter big enough to clean this up yet, so I'm better off just to leave it as it is, maybe take a block of fine grit afterward with a known good surface on a block, just give it a quick sanding once I'm done. The scale can stay. It's time to draw the bolt hole circle. What we're going to do is we take half of 3.74, which is 1.87, and what I'm going to do is make a scratch. There we go. Again, as long as we're within a few thousandths, we're fine. There's lots of slop in that. There's lots of slop in that slot on the lathe itself. So I don't know if you can see it in the, well, maybe you can't see it in the camera there, but I can see the scratch now. I can see the scratch lines. Now the trick for getting two bolt holes lined up at once is I'm going to use my 45-degree square like this. Machinist square, well, try square anyway. As long as I go through the center, as long as I go through the center of the center mark, and I'm butted right up against one of these square edges, sorry about the head if it's in the way, and I should be able to do that, and that. Yes, I could set up in the rotary table and do all that, but for the accuracy this needs to be for this part, it's not as necessary. Yes, it's cool to see rotary tables in use, but if it's accurate enough for your purpose to use a simple method, why not? Yep, we'll go with that. Center mark, bolt hole circle, groovy. And it's not gonna happen. Crap. Nope, that's not gonna happen. I would need a bigger lathe for this to drill that out and do all that from here. So unfortunately, we have to do it on the mill. That would have made it so much easier on the lathe, but not going to happen. So now it's time to locate and drill that center hole. I have a small point in the chuck, and that helps me to see exactly where the center of the spindle is pointing. That's right in the bottom of that hole. Lock off the table. I'm going to have to use the boring head and work out in steps. Using a facing boring head would be nice, but I don't have one. And they are serious money to buy one. Trick is I have to use longest tool method. I could spin this a little faster for the center drill, but I don't see the need to. I don't really feel like having to change the speeds right at the moment, because you have to change belts. Now this is not a through hole. On the plan, it says bottom of the hole, the flat part needs to be 480 thou. 480 thou-ish. 0, our DRO, and start going down. Now I'm going to go to a full 5 inches with this, or not 5 inch, half an inch, 500 thou. Because it's okay if we have a little dimple in the bottom and the middle. I mean, I drew the plan, I can make that the decision. It just can't be too shallow, or else it will interfere with the pin. Well, we're about 490. Put the boring head in, ground up a tool, one of those cheap brazed carbide ones. Tried to put a fair amount of clearance on it, a little bit of rake on it. To touch this off, let's use some nicotinometer paper. In the neighborhood of about 1,000th. Right there. That is going to be our 0. A little bit of shake, but not bad. You can see one thing I'd like to do though. I can see where the chips are starting to pile up in the hole. So let's at least use the air function. Try that. Well, it actually takes light cuts beautifully. That being said, because it takes light cuts beautifully, it's going to take a while to get this done. I'm going to pause this and bring you all back in when we get closer to finished dimension. We're at 1 inch 2/1000. Just put in 11 on the dial here, which, if that's 11 on radius, which is what it looks like is happening, this should give us our final. This should give us our final diameter. As I say, it's shaking it a bit just because of the imbalance of the boring head. The machine isn't that big. Ah, yes, someday maybe a Bridgeport. Oh, that is a nice surface finish in there, surprisingly. There we go. 1 inch 24.5 I had to lower the head, and I changed out the boring head for the chuck. That's in the bottom of that little pit. Through. Oops. But I mean, you get the idea. We're drilling 4 holes. So you've seen number 1. When you come back, all four of the holes will be done. We have 4 holes. Next step is to start cutting the slots, and I'm going to make 2 changes to the plan, one of which by necessity, the other just personal choice. The first off, the one by necessity, the T-slots call for the wide part on the bottom here being 7/8 of an inch to clear the bottom of these T-nuts. The slot going upward, this is just shy of a 1/2 inch, this taller section here, so that'll fit into it right there. Well, further in, of course. The only issue is I don't have a 7/8 end mill. I thought I did, but I don't. So I'm going to be doing all of this with a 1/2 inch end mill. And so for that, what I think I'm going to do is I'm just going to mill the full groove first for each one, mill the full groove, and then offset the end mill, It won't be a full radius on the end, but it'll still work for what I need it to do. I thought I had a 7/8 end mill. I was wrong. I'm not going to buy one for this, so we're just going to go with what I have. The other thing I'm going to do by choice, not by necessity, is instead of being 3/4 of an inch in from the end, I'm going to come an inch. It just leaves a little bit more meat on the end and makes this plate just a little bit more rigid, so that's what we're going to do. We're still going to come in 3/4 of an inch from the side. So there. Alright, so I got 2, 2, and 2. The slot on this side, I'm going to have to take and flip the piece of material around in order to get that slot, because the table just will not reach over here. So I'm going to do these two first, then flip it around. I'm going to set the one work stop here. There we are. Another work stop. There. Now the X can't move any further than that either way, so no matter how many I can just keep passing it back and forth, and I get, as long as I don't go crazy, I can come up against my work stops. I wanted to make a drill hole all the way through using a 1/2 inch drill to make cutting the slot easier. Unfortunately, I don't have a stubby 1/2 inch, and being a column mill instead of a knee mill, I can't move the knee down to put the other tool in. I dug through my stash. Best I have is a stubby 13/32. So now that I have end holes drilled, and I'll just use this 13/32. That's as close as I have. It'll still make things easier than having to try plunge cutting. Well, that, and I'm going to use a new, well, straight out of China end mill, and well, it's not center cutting, so I have to relieve the center where it's going to be going through. A bit of motion lotion. Those are the two ends to our T-slot.